Hello and welcome to this lecture where you are going to learn the basic intuition about two tracking algorithms, and the first one is boosting, as you can read here. It is a slow algorithm, does not work very well, it's not so efficient, and it is based on the Haar cascade classifier with the AdaBoost algorithm. This is the algorithm used for detecting faces and objects with OpenCV. It is one of the simplest techniques for detecting objects. Training is online, meaning that learning happens when you want to track an object. It uses the concept of positive and negative images. The positive image is the object you want to track, while the negative image is the background. For example, in this image here, you must create the initial bounding box by selecting the object to be tracked, which is the positive image, and the rest of the image is the negative part that does not have the object. For example, the house, the wall, the people here, and so on. In short, 1 if it is the object, and 0 if it is the background. We can read the definition here. The initial bounding box, this blue bounding box here, is the positive example, and the rest of the image is treated as the background, the negative examples. We can consider that this image is the first frame of the video, and this one is the second frame, in which the person has his back turned. See that we still have the blue bounding box that indicates the object, and two other orange boxes were created, which are the negative examples. Of course, more boxes will be generated and not just two. The next step to continue tracking the object is to generate the probabilities for each one, and the one with the highest value will be considered as the positive bounding box. Here, the blue box has the highest probability compared to the others. It's similar to this slide here, where the goal is to select nearby bounding boxes and return probabilities to each one of them. And that's all for the basic intuition about boosting. The next one is MIL, Multiple Instance Learning, and generally it has better results than boosting. The training is quite similar, and see that in this image we have the positive examples in green. Let's suppose you selected only this region of the image where I am pointing the mouse. Then the algorithm itself creates other bounding boxes to increase the image area. As you can see here, there are two additional bounding boxes. Instead of using just one positive example, there are several others that are created automatically. On the other hand, negative examples, these red rectangles here, are also created far from the positive examples. In short, rather than just considering the object's current location as a single positive example, the algorithm looks for positions around the current location to generate several potential positive examples. Since there are 3 positive examples, the probability of selecting them is greater than if we had only one positive example. Again, as for boosting, probabilities will also be generated and only one bounding box will be selected to continue tracking the object. This other image shows this process in more detail, where you can see the positive examples that are around the face of the person. Shift to the right and shift to the left. When a prediction is made, only one of these regions will be selected, the one with the highest probability. We can also look at the negative examples that are far from the positive examples, with these parts of the shoulder of the person. The advantage of this algorithm, if compared to boosting, is that even if the object's current location is not found exactly, if we use these other bounding boxes here, we can still tracking the object. And that's all for this basic intuition about these two algorithms. And in the next lecture, you are going to understand the intuition of some more tracking algorithms. See you there!